Then. Okay, great. That looks like a lot of things that I do, right? I'm actually more like a developer. You know, I'm still a developer. I started when I was like 9 years old, and I use programming to test things, experiment. So even if I'm the CEO, you know, I still have to deal when we create new products, or you know, I still play and we try things. You know, we get things really sometimes doesn't work, so we have to keep going. So I'm still, you know, very hands-on in that regards, as you can see. So what I'm going to talk today. So just let me know if there is something I say which is not clear. So I'm Italian, so you know I'm doing my best to speak okay in English, and hopefully the technical jargon it's easier for me. So let me try to kind of introduce what I'm going to do. I think this is pretty new. So have you heard about privacy, GDPR, all these regulations? Yeah, the problem with I mean, if you're aware of this, is that everyone is talking about GDPR, about fines, about you know, kind of fixing it with, let's say, a consumer-facing approach with disclaimer, privacy disclaimer. I'm not sure if you received, just before GDPR triggered, a lot of emails saying our privacy policies changed and stuff like that. So that's how privacy is pretty much addressed right now. So you have kind of the legal framework, okay? And then you have you have tools, okay, which are kind of a little bit old because they're designed for compliance. So it's kind of document based. You have to enter a lot of things that you do, but it's all based on whatever the officer provides, you know, to the tool. So it's just like Word, pretty much. It's like editing a document. So and you probably heard about all the leaks that are going on. You know, it's really bad. And GDPR actually is not being enforced as it should be. So it should be like up to 20 million euros per incident, or 4% of global turnover. But fines, there are some huge fines. But then if you look at the small businesses, the fines are like 100K, 400K. So I think I'm not really happy about that. I mean, I think it's I think that privacy vulnerability is as serious as a security vulnerability. So it's the same. So it can be even worse. So what I'm trying to do today, it's going to be kind of it's going to be interesting. I'm going to try to kind of get down from 10,000 feet to, let's say, 1,000. Okay, and say, how can we do something today with privacy? Okay, but really hands-on. So because honestly, we were looking at, okay, let's see what we can use for our company, or let's see what we can do in terms of privacy. And there's pretty much nothing available, freely available. If you look, I don't know, privacy detector, privacy scanner, or whatever, you find a lot of consumer-facing tools, right? Like DuckDuckGo or VPNs or stuff like that. But you don't typically find anything to address the privacy within the application. So, like, how is the application managing personal data? So it's not about XSS injection. It's about how that social security number is actually being processed within the application. Okay, so right now the tools, what they do, this huge, let's say, the most modern tool, what they do, they pretty much scan your repositories, but the application is, no one knows what goes on. So the application could just send a social security number to China, and you wouldn't know, right? So it's a kind of, I see a sort of correlation with application security somehow. So, like what OWASP pretty much addresses, but on the privacy side. So, and the good news is that we have a lot of technology today that is just out there, and it's not, at least, in the publicly, it's not being implemented, used. So if you look at it on GitHub, anything with privacy related, you're probably going to find a lot of good, let's say, infrastructure, like let's say AI infrastructure, or really good stuff, but low level. But you're not going to find something that solves a specific use case. And in privacy, I think I just found one project from IBM, which was kind of trying to do something, but it's really an experiment, right? So. So what I'm pretty much, when I say grassroots approach, you're going to see that it's going to be, let me keep going. It's going to be about how can we do, kind of let the developer own privacy. It's a very controversial term, because privacy typically, how it works when it's implemented, there's the upper management, the data protection officer, they pretty much negotiate with vendors, and then they say to the developer, this is what you have to do, right? And that might be too late, or might not be the right thing, So what I'm proposing is actually a bottom-up approach. I'm not saying that the developer or developer, architect, project manager just disconnects from the organization, but I believe that you can do a lot, without really, waiting for the corporate, the upper management to tell you what you have to do. So, and when that happens, you can actually act upon that, right? You'll be more prepared. So, well, I think this definition doesn't need any comment, right? I think it's a little bit too generic, but I think it's fine. So there's this professor, Anne Cavokian, was the first person to introduce privacy by design. And she introduced it way before GDPR, okay? And, but now GDPR included that term in the regulation. So pretty much, I think this is also pretty common in kind of quality attribution security, right? You want to be proactive. You don't want to wait for, to get into some vulnerability. So that's, when we say preventative, we mean that you want to protect the personal data. You want to make sure that the personal data is not compromised, okay? So, and you don't want to wait for that data to be leaked, because that's going to be too late. It's going to be in the deep web or somewhere for someone to use your identity, right? And privacy as default is like, that's pretty interesting. If you download any app, it's pretty typical that all the privacy settings are actually against you. So it's quite interesting. So you have to go to the privacy settings, and then in some hidden corner, where actually it's grayed out, and you have to press like 3 times, you have, disable privacy, and they say, are you sure? Yes, I'm sure. Are you really sure? Yeah, I'm sure. So that's how it works right now. And that's what privacy by default is saying, is that by default you should be private, right? And privacy embedded into design is just that. It's actually, there's some, it's actually a little bit redundant. It means that the application should already be designed to protect personal data when that data is passing through the application, right? Full functionality. That means that, let's say, if you want to use a VPN to protect your origin, right? You don't want your IP address to be exposed, right? Because you don't want to do it. You want to keep, private. It's not really privacy, but that means that you don't want to lose any functionality because of that. So if you block, for instance, I don't know, if you use an ad blocker, right? You don't want the website to tell you, no, you have to see my ads. So I'm going to kind of create a really bad user experience for you. So you don't want that to happen. So it means that if you want to keep private, you have the right to be private without your user experience to be affected. Okay, that's what by default. But and then end-to-end security is pretty much making sure that from point A to point Z, you're covering all the kind of the the information flow. You don't leave any part, because you might encrypt maybe 99% of the communication, but then at some point you're sending some personal data plain text, and that's actually the same as nothing. It's the weakest point. I mean, it will compromise the whole architecture. So, which is the same in security, I guess, right? Visibility and transparency. Well, that has to do with, I'm not sure if you noticed, but it's very difficult to access all the data they have about us. Google stores a lot of data, for instance. Facebook, they have a lot of data about us, which is not only the data we enter, it's actually the data that comes out from the analytics process, and they are profiling us. They're linking our data, so in very interesting ways. So they know much more than what we think. And I would love to have some sort of, option where I can just opt out, or I can remove whatever set of data I want. And that's part of GDPR, which is right to be forgotten somehow. So you have the right to be forgotten. But that's, it's going really, really slow. But I'm not going to talk about that, because that's like more on the it's more on the legal, more on the user experience. I'm going to focus more on that, the privacy embedded into design, because this is a huge, as you can see, this is like, to me, it looks like a new wave somehow. It's something that it's built on top of security. It's the same, to me, it's not privacy and security, it's privacy kind of augmenting security, right? And this is old information. So, and there are so many leaks we're not aware of, and because, now with GDPR, they are actually forced to, to kind of, expose that leak. But losses are much more than that, I know. So, and this, after that, we had, Equifax, so, and many other events. There have been some very significant fines for British Airways was like 300 million euros. So there are some significant fines, but small businesses, as I said, they're not still very affected. So this is interesting. This is something some of the things I mentioned before. So we have several challenges now. So I think the first one is really tough, is that what actually happens also somehow with security. So privacy, it's end-to-end. It happens, it's kind of permeates the whole organization. So that means that, and not only organization, you have to also consider, all your, let's say, your service providers. For instance, the cloud. You're sending personal data to the cloud, and who's responsible, who's liable of that, right? And how do you check whether, let's say, Amazon is protecting your, your repository, your S3 repository, for instance, or encrypting? There are many things you do not know and cannot know. So that's a whole challenge, because it's not enough to just protect the app. You also have to protect all the different endpoints. Well, this, I already mentioned regulation. And the only body of knowledge I mentioned before is privacy by design. There's this, this very high level information, and kind of it's a body of knowledge. It's very high level directive, but it's not actionable. At least that's what I think. As I mentioned before, there are no tools. The tools, there are tools you have to buy from some huge, some big, company and a vendor, and the tools are very difficult to install, to implement, because they have to access your repositories. So they also need to be, kind of, there are a lot of NDAs and things that have to be signed off for that vendor to work with, and do some proof of concept. So there's a lot of friction, even if you use a tool. And all that tools will just, as I mentioned before, they will focus on just the pretty much data. They are scanners. You connect with the database, and they just scan and look for some it's kind of a fingerprint of personal data, which is fine, but you're just it's the tip of the iceberg as far as I'm concerned. And the other thing is that there's privacy and there's security, and it's like different worlds and disconnected. And I think there's a lot to learn from security that can be applied to privacy. It's not me. There's something I'm gonna mention that is it's called privacy threat modeling. And this is, it's not new, but pretty much, I think it's extremely powerful. I mean, it's a conceptual framework, right, on top of Stride, but and specifically for privacy. But it's still, you can see that there's not too much traction. I believe that, once again, we can leverage the threat modeling discipline in privacy pretty easily, and it's really good work. I'm gonna discuss about that a little bit. So what I'm proposing here is that, and kind of inspiring, do you know Cathedral in the Bazaar? It's Eric Raymond's. It's a sort of paper that it's based on how open source, pretty much the Linux kernel was successful, and how pretty much the governance model worked. So we were, so we are used to a more hierarchical model where, this is the use case, here are the specs, just implement it. Even if you do agile, I mean, it's still, top down somehow. So with open source, and I've been a contributor since 2004, and we created an open source project, and then I bootstrapped a company behind that. So I'm kind of aware of that. It's a totally different way of working, because it's much more horizontal. And you get features and which might be interesting. Now it's pretty common with the pull request from GitHub, but at that time it's like the whole process is totally, let's say, bazaar-like. I mean, it's like chaos, but it works. Eventually it works. So eventually you get, at some point the application it's a little bit of a Frankenstein, right? But then it's very aligned with what users want, because the user is actually the developer. He's kind of scratch his itch, right, and say, well, I need this, so I'm going to do it. Here's the contribution. So we had a lot of that, and I think it's a great model if we can apply these to privacy. So kind of that the bazaar is a kind of word that looks a little bit harsh because it's like chaos, but I think it's it promotes this collaboration, communication, among all the actors. And I believe that, once again, it has to be grassroots, if you want it to work, because there's no time, okay? There's no time, and developers that already are, let's say, security conscious, they can already make a lot of progress with privacy without buying expensive tools. That's what I'm saying. You can build or you can leverage whatever is out there, and then the tool eventually will follow. So this is a kind of comparison. So, when you implement privacy, you typically have a policy, HIPAA, or whatever, or regulation, and you have to implement it, right? The problem with regulation is that they don't tell you how, or they tell you the what somehow, but it's a little bit gray. So what I propose here is that, so communication flow change from hierarchical to graph, which is what the bazaar model mindset proposes. Going from the silo to connect privacy with the enterprise security architecture. So kind of start working using that as a sort of baseline. And then right now, as I mentioned before, companies focus a lot in infrastructure, like data repositories. And what I say is that you should start from the applications. From the application, then you'll know where the data is flowing, and you protect just whatever it's actually being exposed by the application. Maybe you have let's assume you have some database which is under the desk of some IT guy. You don't care about it. Maybe you care about the personal data within in that workstation, but that workstation or server is not really connected to anything. So it's not so bad. I mean, you have more interesting things to care about. So the application will tell you by the information flow which infrastructure pieces are interesting to you, because the application is pretty much the orchestrator of everything. So that one, it's a way to prioritize also. And then also here's right now, companies, they think that they buy a bunch of solutions, they're protected. No, it doesn't work that way. In security, same thing. So I still believe that you have to try to you can buy stuff, but I believe in building some sort of internal, let's say, capabilities. Okay, So before buying, eventually you buy, you adopt, you build, but you have to already be aware and, let's say, knowledgeable about security and privacy before you buy any tool, right? So I'm not sure I'm going a little bit fast, but so here's do you have any questions so far about the kind of the whole concept? I'm kind of proposing. Is it clear, or just interrupt me? It's great because it's something that it took me some time to kind of put it in these words. So just interrupt me. Really, I just wanted to make it two-way. So here's I'm bringing here PrivAPI. So as I mentioned before, I'm lucky that I can pretty much experiment, and I'm very involved in research. So one of the, let's say, outputs of our research was this PrivAPI product. It's not, we don't want to monetize this. It's just an experiment, okay? Which is feeding other experiments, which is, and then eventually we have a new product or not, who knows? So the idea here is it's not to present the tool. It's really, I would say, it's kind of a prototype, but it shows how with little effort and, let's say, without a lot of, let's say, being a, some sort of AI expert, you can still do some stuff because the technology, all these frameworks are actually have improved in terms of usability, and they're abstracting a lot right now. So what I'm proposing, many people think here, well, AI, like, no, that's too much, or it's like a new, I don't know, I have to do a PhD. No, you can do stuff. It's not going to be perfect, whatever, but at least you can start doing something. And the effort is not in the actual implementation of the solution, the AI solution. And when I say AI, it looks a little bit like, I would like to demystify that, but it's pretty much statistics, okay? It's hardcore, and there are many things going on, which, you don't have to be aware of everything to do stuff. But, there's this product I'm going to talk about called Keras. Does anyone know Keras? Google's Keras? You know Keras? Okay. So I think Keras is pretty interesting because before Keras, you had to work with a specific deep learning stack. So like TensorFlow, which, if you look at the code, is much more involved. If you want to, implement your AI classifier, now we're going to talk a little bit more about that. You have to do some heavy lifting. And now with Keras, it's pretty much more like a plug and play. You build. Think about like a sort of information flow and what you want to happen in every single phase, and there are a lot of variations, a lot of different topologies. You can invest if you want a decade in that, but it's much easier. So and it's accessible. It's not going to be perfect, but at least you're going to get somewhere probably. So the real challenge, here are the challenges. So when I started with this, okay, what is the first challenge? People tell you about, okay, Google is open sourcing Keras, TensorFlow, whatever, all these fantastic toolkits. The great problem is the data. If you don't have the data, it's totally useless. So the data is what really drives your the quality of your prediction. And we're gonna see what kind of prediction we're gonna make. So that was the main challenge. So I didn't have any data. I'm not Google. I don't have access to something to train a model. So in AI, let me rewind a little bit. Just to, I'm going to try to explain, but it typically works in this way. As a security guys, we're used to, when you want to protect something or whatever, to build rules, right? We start saying, well, if this user is coming from this IP address, you build these access control rules, whatever, but it's very rule-based, based on the knowledge we have about security, about vulnerabilities, and kind of reducing the attack surface, right? But in machine learning, works different. So you don't create the rules. You just feed the let's say the engine with data. So with data, and then you have to label that data. You have to tell the system like, okay, this is something insecure flow, and this is secure, this is whatever. You have to classify it somehow. It's called labeling. Okay, and when you provide that, you kind of, the output of that is some sort of, let's call it brain, which has all, it kind of create a lot of inferences based on that data. So somehow all the rules that you didn't build manually are encapsulated pretty much there, based on observations of the data that the system made about the data. Okay, so within machine learning you have like let's say the shallow learning and the deep learning. And the main difference to me is that the shallow learning, you have to tell the AI engine what do you care about. So for instance, if you're analyzing a flow, you care about maybe whether that's an encrypted flow or not, right? Or you care about whether they're using HTTPS or they're using there are some sort of patterns in the URL. So you have to implement all that. It's called feature extraction. So you have to say, okay, this flow is actually insecure, or it's not HTTPS, not insecure. It's this flow, it has a URL with some parameter which is, let's say, it looks like flagged or something like that. So you have to build that. So and then it learns. You feed the system with the data, and you'll get the model. But you still have to implement this feature extraction process, which requires know-how, of course, because you have to know what is relevant, what is not. If you just pick up something that is not relevant, then the prediction quality will be very low, because it's not going to look at the really important things, right? So, and deep learning is pretty interesting because it doesn't need to do that. So you're gonna provide the data, and the feature extraction is gonna be, let's say, automatic. Okay, so it's gonna learn all this feature by itself. Now, what's the challenge is the amount of examples. So in order to learn all the different permutations, variation, all that, you have to feed, the learning process with a lot of data, and not only a lot of data, a lot of diverse data. So a lot of, I don't know, let's say an HTTPS data flow, but then maybe you have a RESTful API data flow, maybe you have, just a plain old JSON file. So you have to, it's called kind of generalizing. You have to try to feed it with good data, because if the data is not good, you're gonna get a really bad prediction. So the other thing is that even if you use deep learning, it's still supervised learning. What that does mean? It means that you still have to tell that specific piece of, let's say, data is actually whatever, something. You have to label it. You want to say that that's insecure or that's secure. Okay, so you have to do that, because if not, the system will not be able to classify. Okay, so I mean there is also supervised learning, but it's used for pretty much analyzing and kind of clustering, and it's not going to give you a label as an output. You want to know whether that traffic is secure or not. So you have to tell the system, all these examples, what they mean pretty much. Okay, this secure, this unsecure. So consumption ready. Well, of course, it's PII is confidential information. It's personal data, right? Personal data is not going to be out there just clear text. And then, as I mentioned before, we always try to learn from existing implementations, and there's so little that you kind of have to start from pretty much from scratch. You have all these pretty good frameworks, but still, you have to start from scratch. It's a little bit. Let me see if I can. I'm not sure I can zoom out, but are you able to see it? Well, it's a little bit small. So this is how it works, but I have another diagram. I'm kind of splitting. Okay, this looks better. So first of all, we don't have the data. So what are we going to do if we don't have the data? We are going to generate, let's call it our own data. Okay, so. And that's pretty dangerous, because if you generate your own data, that data probably is going to be biased, or it's going to be just what you think about traffic. For instance, information flows, but the reality is that might be totally different. So how can you create an artificial, what's called a synthetic data set that is based or kind of can be applied to real world situations? So, and this, once again, this is just an example. You can spend a lot of time just dealing with this problem. It's called data programming. So you can just spend a lot of time just improving this. But with a very simple model, and I'm going to explain how it works, it's actually generate pretty good, I think, data. Okay. So how does it work? What I pretty much did, OpenAPI, it's pretty much a descriptor of RESTful APIs. So it's a spec. It's like the old, I'm not sure how many people know the WSDL, old stuff that younger people don't know about, but it keeps being reinvented. Okay, so it's a kind of WSDL for RESTful API. So WSDL, that's how it's spelled. So what we're doing is pretty much the following. I had access to all these descriptors. It's public, okay, and these are pretty good quality. So descriptor, it's pretty much like a spec that what a RESTful API is actually expecting. So you build some sort of message that conforms to that, and then pretty much what you're going to get back as a response. So it's a way to structure the communication. Okay, when you're connecting, for instance, with Amazon, with Google, YouTube, through RESTful APIs, you wanna know what you're gonna get back so you can process it, okay? And the other usage scenario is that if you have that descriptor, there are a lot of products that can create the actual client, the actual stub that will, connect you to Amazon without having to implement anything. You just provide the spec and you get the code back and you just start using that. That's pretty cool. Okay, that's also was pretty common back in my day. From WSDL, you could generate the stubs and the skeleton, both. You could also generate the server side of it. Okay, so it's so what I pretty much did is I got into the descriptors, and then I tapped into one of these toolkits. These toolkits are meant to send data, right, and to receive data, and they're not meant to generate data set. So what I pretty much did, I just tapped into it. So instead of sending anything throughout the wire, I just captured that. I say, okay, give me the spec, and I'm going to take the spec. I'm going to generate my own message. So I'm not going to send anything. So, but the cool thing is that I could reuse somehow all the infrastructure, but at some point I just took over and said, well, now leave me the spec so I can digest it. I can do whatever I want. And the toolkit was fine. Python, you can pretty much hack anything with Python. So that's what we're doing. So we have I think there are like a few thousands of APIs, and pretty much, yeah, we get the spec, and we can generate those fake requests, those mock requests. Okay. How do we generate those mock requests? Well, it's interesting. Since we took over that process, we can leverage a lot of, Python has a really good random data generators, so that are used for something different. So what we pretty much have is like a sort of schema where you say, well, this is a social security number, and you have the corresponding, let's say, generator for that. So it's not just generating strings or whatever. It's also, let me check the time. It's also generating a social security number, phone numbers, real, looking. So, and this library is called Faker, if anyone wants to try. Second thing, there are some fields with, we got regular expressions. Regular expressions are used to match, pretty much text. We use that in security a lot, right? So what we wanted to do is kind of, instead of using a regular expression to match text, we want to actually to generate text from regular expressions, okay? Because regular expression is really, it's a spec also, but of the specific field. So you got a regular expression of social security number. So what we wanted to do is actually go the opposite way. So we had regular expressions, and we generated fake instances of valid text based on that regular expression. So we work at the, let's say, at the request level and then at the field level. So that was pretty interesting. And Python, I mean, I'm not a, you know, I'm a pretty a little bit. You know, I love programming languages. We develop programming languages and domain-specific languages. Python is really, it's really very, you know, hands-on, and you have so much out there. So that's why, you know, we use Python, even if it's not my maybe favorite programming language, but it's very hands-on. There's so much. The community is great, and you can find anything, which doesn't happen with other languages. So this is pretty much how it works, okay? And the other problem that we have, okay, once we have, okay, we generated this fake message, okay, using fake fields that look pretty real. Okay, now we have to tell the system, what is this, right? Because it's not enough just to generate the message. So in order to do that, we have to automatically, you know, we didn't want to send that data set to, you know, there's an Amazon service that they can label data sets, right? We didn't want to go through that. It's expensive, it takes time, it requires some expertise. So we did some automatic labeling, which is a pretty simple approach. I would say, you know, maybe too simple, but it's just the tip of the iceberg. Then you can do something much more sophisticated. We just detect some trigger words. Okay, so okay, you have a SSN and some, you know, something SSN looking in the name of the field, or you have this field or something. So we kind of find for hints that that message could be confidential. It's really simple what it does, but even with something so simple, it doesn't work that bad. Okay, if you want to explore all this area, it's called data programming, as mentioned before. There's a whole toolkit that does that. It's called Snorkel, and they use machine learning to do the labeling. It's pretty cool. Okay, so, but I didn't want to get into that. So, because it's a never-ending story. But at least, you know, if you wanted to do that, you know, right now we just look for some very basic hints like pattern matching, like SSN or stuff like that in the configuration file. But if you use a machine learning model, you could actually do some natural language processing, be smarter in terms of, okay, it's SSN, but then, you know, it doesn't look like there's anything else that's confidential. So maybe I'll flag it and say, no, it's not. I just consider it like maybe not confidential. But it's difficult. You would need to build a separate model just to label data sets. So as you can see, it's a huge board. This is just, you know, the tip of the iceberg. Other problem I had, APIs typically don't send PII over the wire. So you don't get, you know, if you want to submit a request to Amazon, you won't probably submit social security number. You probably submit an ID or something, and they will, you know, link that ID to some confidential information. But that's not gonna pretty much go throughout the wire, typically. So this is a different problem. So you have to, you know, I had very little positive examples. So like when I say positive, it's like, you know, it has confidential data. So in order to address that, I use a very simple technique. I base on let's say, on an example confidential request, we can create others. Because we know that's confidential, okay, let's create maybe 20 more. Okay, so because you have to get to a point where you have what is called a balanced data set. It's like 50-50. You have, you know, has PI, it doesn't have PI. It doesn't need to be 50-50, but if you have 10-90, it's very ineffective. It doesn't work. So you have to pretty much teach the system, you know, with providing a sort of, as I mentioned before, a balanced data set. So this was the technique. Once again, if you want to do this in a more sophisticated fashion, you have you can also use machine learning for that. You can use a supervised machine learning to do that, and it's called principal component analysis. You can also, you know, there are many ways to do that which are much better than the one I use. But, you know, this is just, once again, an experiment. But this is a whole different area if you want to. So this is what I was, I wanted to also describe, the flow, so it stays in the presentation. It's pretty much what I said. Let me see if there is anything. Well, the trigger words I said before. Yeah, and the oversampling of the minority class, which is all these flows that have PII within it. So that's pretty much the data set generation. Once we have the data set, right? When we have the data set here, we have to build some sort of vocabulary, okay? Because the AI or the deep learning machinery doesn't know about text, doesn't know about, it cannot deal with that. It has to deal with something that it's called Vectorize, which is pretty much, think about like a sort of vocabulary where you have a letter and then you have a sort of ID, okay? So you have to associate a specific, let's say, character with some sort of ID, okay? And there are many ways to do that. I've used a very simple way to do that, but I had to build this vocabulary, which is pretty simple, and then once I have the vocabulary, I can just create this vector. Think about a vector just as a stream of numbers, okay? That, if you want to put it simple. So that's what the AI learning process is digesting. It doesn't know anything about RESTful, doesn't know anything about, it's just sequence of numbers, and it's going to try to make sense out of that, right? Associated with the label. So here where I use Keras with TensorFlow, the good part of Keras is that you can actually choose a different deep learning engine. So if you want to go with the Microsoft one, you can do it without changing your code. It's not really like that, but pretty much. So it provides some sort of vendor, remove the coupling with a specific AI engine. Here there's something LSTM. So there have been a lot of advances in AI, and as you can see from the press, it's typically used to kind of analyze pictures, right? It's used a lot for that, and this is like the main application, at least the one I'm seeing. But the same technology can be used also to analyze text. And when I say analyze text, you can use it to in some way to work with language, to English, work with RESTful messages, JSON, XML. Okay, so it doesn't need to be unstructured, because typically when you see AI, you want a lot of implementation of AI in the natural language processing are actually for natural language. You want the machine to understand English, right? And here, which is unstructured, but I wanted something that is actually semi-structured, which is JSON. So I have an advantage there because, the grammar somehow, first of all, there's this, fixed syntax. JSON, has some specific rules, right? Syntax rules. And then every API would have, some similarities. So it's not like, reading Shakespeare and then, reading, I don't know, New York Times. It's much easier to find patterns. So what I pretty much did is just consider the structure, semi-structured representation as just, just text, English. It doesn't really know, but using, natural processing capability, natural language processing capabilities of LSTM. Why LSTM is cool? So when you see LSTM, it's actually deep neural network. There are a lot of, it's called topologies, many different shapes. So every topology has its own strength and weaknesses. Okay, so honestly, it's very difficult to know which one will work. So there's a lot of empirical testing. So you pretty much say, okay, let's see how it works with LSTM. Okay, then let's see how it works with this. So even researchers do that. It's very difficult to know which machine learning algorithm or will specifically work for you. A combination will work for you. So I pretty much started with the LSTM. It looked like the most, let's say, advanced. And the main thing is that LSTM, I would say it's stateful. this is the key thing. When you're processing, let's say, a JSON file, right? You want to know what happened before, pretty much, right? Because you want to have context, okay? So even if neural network actually has memory, of course, there's it's actually the neuron is actually being updated. So there is state, but LSTM is kind of along all these, let's say, deep learning. There's a whole let's say flow of information, okay, that goes back and forth. You can inject pieces like sort of cookies of data that is related with what happened before. And in my case, it was interesting because I wanted to know, I wanted the kind of the machine learning model to also learn how these API requests look like. So for that to happen, I wanted to kind of consider whatever happened before. So if you're looking at the social security number, you want to know that that's part of maybe an object, a JSON object, which is I don't know, personal details, and you want to know that that's inside a customer, and then you want to know that that's inside whatever object, because it's going to also provide some hints in terms of whether that's also kind of looks like a valid JSON, or at least the JSONs that you used to train the system. So it's a way to do some sort of, I would say, the fuzzy parser. Typically you have to parse JSON. Well, it doesn't really parse JSON, but at the same time you're getting whether that JSON it looks like JSON you're interested in, not valid. Okay, so LSTM it's memory pretty much. It remembers what happens before, so you can and injects that into the learning cycle, so you get better output, and then you have the analytics model. Okay, and this is what I explained. Okay, pretty much. Okay. Vector embeddings is the same as vectorizing is the same thing. And this is a prediction phase. It's pretty easy, actually. Once you have the model, you have to test the system against unseen traffic, unseen requests, right? So what you typically do, you need some sort of real world example, and then you just push that into the system. And before you do that, you have to vectorize it. So vectorize it, because this is the representation that you used for training. So everything has to follow the same representation. You cannot just inject text here, even if it will not work. So you have to be careful with that. So the same, let's say, vectorization process you use with vocabularies, all that has to be applied at prediction time with the sample you want to predict on. Okay, so this is the same, has to be the same process, because if you mess it up here, it's not going to work. Okay, so and Keras and TensorFlow, well, the same thing. You're just gonna load the model, and you're gonna get whether that has some PII or not. And this is what I'm explaining, pretty much. So the prediction part is pretty simple. What is challenging is get to a good model, and it's far from perfect. And I've tested with some real world messages. It works pretty well, but with a very basic configuration. I think the key thing with the solution is how you configure it, how you make it more advanced so that you can generate better data. Okay, and what I'm really doing is generate a baseline data set, and then the idea is that you have to feed that with your own flows. Okay, so that you can actually learn how your traffic looks like, but at least you start with something. Okay, and then you can improve it. You can make the model. You can actually update that model. So this is just the creation of a baseline. Okay, with a very simple configuration. So right now, let's see if this will work, because it's actually remote. So I'm taking a lot of risk here. So let's see if I can go back. So one thing about the deployment of this kind of stuff, the learning, and that's why I'm remote actually. But the learning process is actually requires a lot of CPU power, okay? And traditional CPUs are not really good for deep learning. So that's why you have to use, for instance, NVIDIA. NVIDIA, it's like, these are like native CPUs that are designed to work with vectors, for instance, to work with this kind of system. Yeah. You want to try to go fast. So right now, this is a box in G-Cloud. Okay, it's a box with NVIDIA card. I think it's a P100. Okay, and for prediction, I don't really need a lot of CPU power. But the problem is that the system has been trained there. So when you train the model in this kind of box, it doesn't work in my Mac. So I need to run the prediction here. So let's do the following. So I have here several like example messages, okay, example requests. For instance, this kind of looks like has some personal data, right? Something that could be considered confidential. Are you able to see? Okay. The interesting thing is that I never trained the system with, I don't think so at least, with information from YouTube or the Magento schema, okay? So this should be like unseen example. It doesn't know anything about Slack, okay? So you want to try with stuff that is really different from what you learned to do, to run the system with before. So what I'm doing here is just run this shell script, which is going to invoke the prediction, okay? Let's see if it works. Okay, loaded model and generated a prediction, that's it, okay? Of course, these are very few messages, but the performance of prediction is really, really good. The learning is very slow, but the prediction is extremely fast. What it does, it generates a CSV file, okay? And you can see that this is really, if it's sensitive, it's actually, it's 1. If it's not sensitive, it's 0, okay? So this is the, I would say, the important thing. And the other thing is the probability of that output to be, let's say, to be correct, okay? To be true. So with Slack, for instance, let's see Slack. It says that it's not confidential. Let's have a look at Slack, okay? We can have a look at predict Slack. You can see, it doesn't look confidential, right? Complete this task, complete whatever. But then, if you go, let's say YouTube, okay, that's also an example YouTube message. It doesn't look confidential. Okay, there's nothing that looks confidential, at least at first sight. But then it's saying the COPA, this one, JSON, it's confidential, and there is 93% of probability that it's confidential. So let's have a look at it. And actually, there is a lot of information here. There's an email. There are some hints here: authentication, credentials, names, usernames, first name, last name. So this looks confidential, and it's saying that it is confidential. Once again, this model is trained. It's with really, really basic configuration. I'm going to show you that if I have, 1 more minute. So this one is saying it's confidential. So you can see here, COPA confidential. It's a 1. See here, this is a 1. Okay, 93%. Then we have Magento. Let's see. It's saying that's confidential, but it's not so confidential. Well, there's an email. There's a first name and a last name. It is, but if you look at the previous message, has much more PII. It's a bigger message. So in this case, it's saying it's confidential, but the other one is considered like more, more confidential because there's more data exposed. Okay, more personal data exposed, more PII exposed. Let's see at the last one. It's saying that Atlassian is very confidential. Okay, it's 96% of chances that it's of probability. So we can see that, and we can have a look at Atlassian. Well, there's something here, which is password. He doesn't like, it looks like, password is something you don't want to communicate over the wire. So there's also an IP address. So pretty much it works. I actually found a lot of corner cases, but it's not because of the actual AI. It's because of the data. And you wanna see just to finish this. Let me show you the configuration file. If these are kind of all these knowledge about all the different fields that are considered PII, right? And their format. And as you can see, it's not very extensive. It's not even considering a lot of different permutations or stuff like that. So you can see it's a couple of pages of code, nothing. And so this actually has to be improved and adapted. You have to do it much better than what I did here. But even with this very basic configuration, it's giving pretty decent output. Okay, and if you look at the code, it's open source. Okay, so you can pretty much go here, and let's see. Oh, sorry, so. Well, it's not. I don't know why it's not showing here. Yeah. So that's a post I made about it's a kind of tutorial. It's not a tutorial. It's like the story of of the PrivAPI, how it started, on how it works, and then that's the open source project. So there's a lot to do. So we're always looking for contributors, people that want to move this forward, and you're going to check the code and you'll see that. I believe in that if you really want to do it, you can. Pretty much anyone can work on it and improve it, and it's a lot also about how you customize it. You don't necessarily need to work in the code. You can just configure it better. You can generate better data, and that's not related with AI unless you go with a machine learning approach. So that's it. Thank you.